Welcome to this lesson where we'll be looking at parallel and perpendicular lines. Before we start, you need to know how to find the equation of a straight line graph. And I have a lesson for that on the channel, so go and search it if you don't know. So what are parallel and perpendicular lines? Well, when two lines are said to be parallel, it means that they have the same gradient. And when two lines are perpendicular, it means that one of the gradient is the negative reciprocal of the other. But I will show you that through examples, so don't stress too much for now. Let's begin with parallel lines. So if you have two lines like this, these two lines are parallel. And if I give this one an equation, so let's say y is equal to 3x plus 5, for example, then this one will have the same gradient as this one. So the gradient of this one is 3, so therefore this will be y is equal to 3 with an x plus or minus something. So that could be anything. That could be, for example, minus 10 because it's different to this one, okay, where this one cuts the y-axis. And if I draw another line, a third line, so let's say I draw a third line here, which is also parallel, then again, this line would be y is equal to, again, it has to have the same gradient, so 3x something, okay? So in this case, it could be plus 7, for example. So, in a nutshell, to conclude, parallel lines have the same gradient. We will look at perpendicular later on in this lesson, but for now we are going to focus on parallel lines. Let's have a look at this question here on the board. Find the equation of a line which is parallel to y is equal to 8x minus 1 and it passes through minus 3 minus 5. So what does this question want us to do? Well, we are given this equation of a line. So let's just quickly draw a rough sketch of that. So y is equal to 8x minus 1. And we want to find the equation of another line that passes through minus 3 minus 5. So let's just draw minus 3 minus 5 coordinate right there. So if we were to draw the line which is going through this point but is also parallel to this, what does it look like? Well, obviously it's going to have to be parallel to this line and it will look something like that. Now currently we have no information about this other than y is equal to mx plus c, which is basically the standard equation of any straight line. However, if you remember, I said to you that when two lines are parallel, then they have the same gradient. So straight away we can replace our value of m with 8. We can say y is equal to 8x plus c, and we are going to find that value of c. How? We know that this equation, the line goes through this point. And like I said, do refer to that video I mentioned at the start of this lesson so you can get a bit more practice on this. We are going to substitute this coordinate pair into here. So y is equal to minus 5, 8 times our x, which is minus 3, plus c. And we're just going to work this out. So minus 5 is equal to minus 24 plus c. So now we're going to do minus 24 over onto this side, which will be a plus. So minus 5 plus 24, which is 19, is equal to c. And we have our value of c, so we're just going to replace here. So therefore, plus 19. So there you have it. Y is equal to 8x plus 19 is the equation of the line which passes through this coordinate and is parallel to this other line. Now, before I go on to the next question, you may have noticed in my diagram here that we've got plus 19 and this one, the line which is parallel to, has minus 1. Technically, this line needs to be obviously higher up than that, much, much higher up. But this was just a rough sketch to demonstrate to you the gradient. Now, another type of question that you can get is you can be given two equations or several equations and you have to show whether they are parallel to each other or not, the lines. So here behind me, we have two different equations of lines and we are told, it doesn't actually say it here, but I'm telling you, to show whether or not these two lines are parallel or not. Now, to do this, we need to get it into our format, our classic y is equal to mx plus c format. And as you can see, currently they are not in that format. So we are going to get both of them into that format by doing what's necessary. So in this case, we've got 3y here. We want to get rid of that 3 because we want y on its own. So to get rid of that 3, we divide by 3. So therefore, y would be equal to, everything here would be divided by 3. So therefore, 2 over 3x plus 2 over 3. And we have it in that format. And what's our gradient? Our gradient is 2 over 3. Now we are going to rearrange this one. On this one, it's slightly more complex than the other one because we've got two things on one side here. So we're going to take the minus 6 over to this side, and we get 9y is equal to 6x plus 3. What's left is to divide by our 9. So y would be equal to 6 over 9x plus 3 over 9. Now, on first glance, it appears as though the gradients are not the same. But if you look closely, you will need to simplify. In fact, you need to simplify both of them. So what can you do? You divide by 3. So if you divide this by 3, you get 2. You divide this by 3, you get 3. And you divide this by 3, you get 1. You divide this by 3, you get 3. So the final equation simplified is 2 over 3x plus 1 over 3. And you can see that the gradient of this one is also 2 over 3. So therefore, these two lines are parallel.